Last but not least, we have our last question, which is all about graphing. I don't know if I called it question 31, but I'm going to. How to graph a line. Well, if you get it in y equal mx plus b, you could put it into the calculator, pick off a couple of points, graph it. You can also put in an x and out comes a y, put in another x, out comes a y, and any 2 points determine a line. Make sure that you know how to graph horizontal and vertical lines. X equals 5 is a vertical line. Find where x equals 5 and just draw a line through it. That is x equals 5. With y equals negative 3, find where y is negative 3 and then draw a horizontal line through it. Y is negative 3. Make sure you know how to graph vertical and horizontal lines and oblique lines. The second one was a parabola. You could just put this into the calculator, look for symmetry in the table. If you don't find symmetry, pick a good number of points that center around that vertex. If you want to use x equals negative b over 2a to find the axis of symmetry, you may, but normally you can just get that from the table. Part C was inverse variation, inversely proportional. This is going to look like a hyperbola. So what I did was I got the y by itself. So I want to show you a little looky-see of what this graph is going to look like. If I do 6 divided by x here with the calculator, and I did a zoom 6, you can see how your graph is going to be in the first and the third quadrants, and it's going to get closer and closer and closer to these axes, but it'll never touch it because the x-axis, which is the equation y equals 0, and the y-axis, which is the equation x equals 0, are asymptotes. So these values are going to get closer and closer to it but never touch it. Now, a word about arrows on graphs. If they give you a domain, x is where they want you to graph it, you put endpoints on it. If they don't give you a domain and you're supplying your own x's, you put arrows on the graph, and always label your graphs. For the next one, part D, it was a circle. How do I graph a circle? I find the center. They're always opposite. So this is plus 5, it'll be minus 5. This is minus 7, this will be plus 7. You would plot the coordinate, negative 5, 7, and apply the radius, which is 3, because it's the square root of 9, up 3, left 3, down 3, right 3, and connect that with a compass if you have one. With E, it was exponential, and there's that asymptote again. So 2 to the x happened to be an exponential growth curve. 2 to the x, zoom 6. You can see it's going to be in the first and second quadrants. It looks like it's touching the x-axis here, but it really isn't. It's going to get closer and closer to it. And the asymptote, the x-axis, which is the equation y equals 0, it will never touch it. If we put in y equals negative 2 to the x, which is one of them that I possibly asked you to graph. Again, these are exponential because we have these x's as our exponent. That is my 2 to the x, and this is my negative 2 to the x, which is a reflection over the x-axis. So that negative base made that reflect over the x. When you reflect into the y, you change the x. When you reflect into the x, you change the y. So negative y equals 2 to the x. When I divide both sides by negative 1, gives you that negative base. The other one was, I think, like 1 half. I'm just going to write 0.5 so I don't have to use the fraction feature here, to the x power. And you can see that when we graph this, that it's going to be a decay curve. It's going to be a reflection over the y-axis of the original graph. So that's 0.5 of x, which is decay. All have the same asymptote. Now for the last curve, it was a log curve. And I know these log things freak you out, but I got to tell you they're the easiest things because you just plug this into the calculator. So I'm going to go here. It's actually log base 10, so I could use my big log key right here. Where are you, log key? Right there, right? But if it wasn't log base 10, you can go into your alpha window and use your log base right there. I'm just going to type into y equals log, and I believe it's x minus 5. It is x minus 5. Now do a zoom 6, and you can see that the log graph is going to be in the first and the fourth quadrants. Now, do you see this value right here at 5? That's your asymptote. That's going to be where your graph gets closer and closer to it. A zoom 6 was kind of crummy. Let's try a zoom decimal and see if that looks a little cooler. Well, that wasn't great because the window only goes from there to there. So let's try changing our window. Let's try a zoom, maybe a zoom square. Still no good. So let's change our window to maybe 0 to 10. and graph that and see if we see a better picture. A little bit better. But again, the graph is going to approach x is 5. Why? Because there was some horizontal shifting going on in the graph. Normally the log curve will approach the y-axis where x is 0. It'll get closer and closer to it, but it will never cross it. But here, this was a horizontal shift of 5 to the right. We know that horizontal shifts are opposite shifts. So everything of the log aspect is shifting over here. Now what do I graph? I just go to my table. Start at 0. You can see these are errors here because the graph does not exist there. And it's 6 at 0. And pick some cool points to graph. Some of them are going to be ugly. It's cool. But make sure that you don't just start the graph here, because the graph is going to approach this, and it should go all the way down here as an arrow. So make sure that you might want to sensitize your table and maybe go up by, I'm going to put my plus sign here. If you hit plus, it gives you a delta on the bottom, which you can change your table, 0.5 and enter. And now I can see in between the 0.5 values, and you can see at 5.5, there is a value there. So you want to sensitize your table. Just so your table doesn't remain that way, change it back to go up by ones, but make sure that you're on an integer when you do it. So I'm going to hit plus again, and then go up by ones, and it's going to reset the table. So make sure that when you are doing a log graph, that you get this portion of the graph. You might have to sensitize your table, make it go up by something other than ones to see that portion of the graph. And normally with a log curve, it's still going to be in the first and the fourth quadrants. But normally the log curve will have your asymptote as the y-axis, which is x equals 0. But because this was shifted, it shifted over the asymptote with it.